Okay, we're going to try this with a video lesson today. Sorry I can't be there. Today we're going to continue 12.2 notes. We were talking about the unit circle and discovering all the relationships. Today I want to talk about angles that are in standard position. Whenever you're measuring from your unit circle, you will always start on the positive x-axis and you will calculate counterclockwise. And we talked about this last time, so this would be 30 degrees, 45 degrees, 60 degrees, 90 degrees. If you want to talk about negative angles, those would go clockwise. So if I were to talk about negative 30 degrees, it'd be down here in quadrant 4, which is really 330 degrees. So if I said negative 90 degrees, you'll be talking about 3 pi over 2 or 270 degrees. So positive angles are measured counterclockwise, negative angles are measured clockwise. I want to now give you some more information about the unit circle, more specifically sine, cosine, and tangent. So going back to our geometry days, if we have a right angle, we can use SOHCAHTOA. Typically this in the horizontal direction is x, vertical direction is y. Here's my angle. Could you guys tell me what cosine of theta equals and what sine of theta equals according to this triangle I've drawn? So cosine would be adjacent over hypotenuse, and sine would be opposite over hypotenuse. These both simplify. So whenever we're talking about an ordered pair on the unit circle, typically ordered pairs are x and y. But on a unit circle, we could also refer to them as cosine theta, sine theta. This will allow you guys to answer a little bit more complex questions. For example, cosine of pi over 2, sine of 3 pi over 4, and things like that. While I have this picture drawn, I also want to refer to what tangent would be, and that would be y, which is your opposite over your adjacent. So tangent can now be referred to as y is the same thing as sine of theta, and cosine is the same thing as x. So we can now talk about tangent is the same thing as sine of theta over cosine of theta. Cosine is x, sine is y. We can solve some other problems. Last, on your unit circle, back in geometry days when you had a circle, you had an equation, something like this. H and K are the centers, and since this unit circle is centered at 0, 0, this equation would be x squared minus 0, and then y minus 0, quantity squared, and my radius is 1 because it's a unit circle. So this is the equation of the unit circle, which now we can change it to cosine squared theta plus sine squared theta equals 1, and that is a very important trig identity that will be used a ton in this class. Be sure in your notes that you have these important pieces written down. This is more just to kind of show you where everything comes from. So moving back to our unit circle, I'm going to ask you guys some questions. I'm going to ask you these down here. Cosine of pi over 3, sine of 2 pi over 3, tangent of 45 degrees, tangent of pi. So when your book asks you these questions, or your calculus teacher next year asks you these questions, cosine pi over 3 really means what is the x-coordinate at pi over 3. And sine of 2 pi over 3 is really asking you for the y-coordinate at 2 pi over 3. Tangent at 45 degrees is asking you to find what sine over cosine is. But more specifically, you could say theta is 45 degrees on both of these. You could find out what y divided by x is at 45 degrees. Same thing here. Tangent of pi would be sine of pi over cosine of pi, which is really y over x at pi. So we pull out our unit circle, we can go answer these questions. It will really help if you have the unit circle memorized. Here in the next week or so, we could work on building up towards that. So cosine of pi over 3. I've got my unit circle right here. Pi over 3 is 60 degrees. Cosine is my x value, and if I look at my ordered pair here, I've got 1/2 and then square root of 3 over 2. So cosine of pi over 3 would be the x value, 1/2. So that's all I write for that answer. You don't have to write all this extra stuff here, just what's in pink. Sine of 2 pi over 3, I go to my unit circle where 2 pi over 3 is. That's all the way up here at 120 degrees. Sine is my y value, which would be square root of 3 over 2. If you feel like I'm going too fast at any time, you can pause the video and back it up and watch again. Tangent of 45 degrees means I'm going to go take the y value and divide it by the x value. 45 degrees, my y value is the exact same as my x value, but I could go ahead and show my work in case I get a more difficult problem later with tangent. So this would be square root of 2 over 2 divided by square root of 2 over 2, which simplifies to be 1. I like tangent of anything that is a denominator like pi over 4 or increments of 45 degrees. So tangent of pi, I pull out the unit circle, tangent would be sine over cosine, or my y value divided by my x value. So that would be 0 divided by -1, which simplifies to be 0. I'm going to give you some to try. So once you write these down, pause the video, try them, and then check your answers. I'd like for you to try cosine of 7 pi over 4, cosine of negative pi over 3. Remember, negative just means direction. And then I would also like you to find what angle does sine equal square root of 3 over 2. So sine of what equals square root of 3 over 2. So I'm kind of making you work backwards here. I want you to find all the possible angles where sine is square root of 3 over 2. So pause the video, go try to solve these, and then come back. Alright, I hope you took some time to actually pause and figure these out. Cosine of 7 pi over 4 on your unit circle. 7 pi over 4 is down here. Cosine's my x value, so that's square root of 2 over 2. Cosine of negative pi over 3. Pi over 3 is up here at 60 degrees, so negative pi over 3 would be negative 60 degrees. It's down here at 300 degrees, or 5 pi over 3. And we're talking about cosine, so that is 1/2. The negative here doesn't make you have a negative answer, it just means direction. Then you have to think, for the third example, where on this unit circle does the y value equal square root of 3 over 2? So if I'm looking, hope I'm not making you too dizzy, I'm looking on here for all the y values that have square root of 3 over 2. So here's one, 60 degrees, or you could say pi over 3, either one, you don't have to say both. Moving around, here's another one, square root of 3 over 2. I don't see any others because they're negative. So the answer for this are two answers. We could say 60 degrees, we could say 120 degrees, or you could have put it into radians, pi over 3 to pi over 3. Either one. So you don't have to have both. You have just this one or that one. Next, we are going to look for some more patterns like you guys did on the first day when we were learning unit circle. Specifically, I want you to find all of these answers, and then once you find all of these, then we're going to talk about what the pattern is. So sine of 30 degrees versus sine of 150, sine of 45 degrees, sine of 135 degrees, sine of 60 degrees versus sine of 120 degrees. So I hope that you will pause and get all the answers here, come back and check it, and hopefully you figured out the pattern. I hope you paused it. Okay, coming back, sine of 30 should have been 1/2, sine of 150 should have also been 1/2. Sine of 45, square root of 2, same as sine of 135, square root of 2 over 2. Sine of 60, square root of 3 over 2, and sine of 120 is square root of 3 over 2. I hope that you noticed 30 and 150, 45, 135, 60, and 120 all have something in common. These two angles will add to 180, these two angles add to 180, and these two add to 180. Therefore, their answers all have the same square root of 3 over 2, square root of 3 over 2, and so on. So what you should notice is if I ask you to find sine of theta, that's the same thing as finding sine of 180 minus theta. It's just a pattern. It's nothing to stress over. It's just kind of neat. I was hoping you could find another pattern with cosine, which you guys actually found this last time. I just didn't write it out into some fancy sine of theta equals sine of 180 minus theta. You noticed that last time. Same thing with cosine. You noticed a pattern here. Cosine of 30 degrees versus cosine of negative 30 degrees. And then you should notice something with cosine of 45 degrees, cosine of negative 45 degrees. So pause this, see if you can get those answers, come back and check them and see if you can figure out the pattern. So I hope you paused them. Cosine of 30 was square root of 3 over 2. Cosine of negative 30 just means you move clockwise 30 degrees down here, which is really 330. It has the exact same answer, square root of 3 over 2. Same as 45 and negative 45. So if you were to write that, you could say that cosine of theta equals the same thing as cosine of negative theta. They have the same relationship. This is not on the test. This is just something neat to notice. There's another pattern with tangent that I don't want you to stress about, but I just want to show you. And it's this. Tangent of theta equals tangent of 180 plus theta. That is a true statement. Just to help you on the unit circle, but I think you guys have already noticed all the patterns. If I were to look at tangent of 45 degrees, and then if I figure out, well, that's tangent of, what's 180 plus 45? That would be tangent of 225. They will have the exact same tangent values, which is 1. We've kind of shown that earlier. But you could look at the unit circle. Tangent of 45 is sine divided by cosine. They would both be 1, and these actually, I think some of you guys noticed this last time, they're straight across from each other. So would that be true for all tangents? And then we can talk about that when I return. So this is just the first video of 2 that I was wanting you to watch today. Thank you.